Okay, let's move to the question number 7. Express 5 sine of x plus 1 over 6 times pi minus 4 cos x in the form of r sine x minus alpha, where r is greater than 0 and alpha is less than pi by 2 and greater than 0. State the exact value of the r and give the value of alpha correct to 3 decimal places. Okay, to solve this question, we need two identities. First one, we should know that sine A plus B is equals to the sine of A cos of B plus cos of A sine of B. Similarly, sine of A minus B is equal to sine of A cos of B minus cos of A sine of B. Okay, these are two identities which we will use while solving question number 7. First, we have 5 sine of x plus pi by 6 minus 4 cos of x. So we apply sine A plus B formula. So 5 times sine of A means sine of x cos of pi by 6 plus cos of x sine of pi by 6 minus 4 cos of x. We know that cos of pi by 6 is equals to the under root 3 over 2 and sine of pi by 6 is equal to 1 over 2. So we have 5 sine of x cos of pi by 6 is 3 over 2 plus cos of x remains same and sine of pi by 6 is 1 over 2 minus 4 cos of x. Further solving, we will have 5 times under root 3 over 2 sine of x plus 5 times cos of x over 2 minus 4 cos of x. Further solving, we will have 5 under root 3 over 2 sine of x plus 5 cos of x minus 8 cos of x over 2, and this one is equals to the 5 under root 3 over 2 sine of x minus 3 over 2 cos of x. We need to convert this expression in the form of r sine of x minus alpha. R sine of x minus alpha is equals to r times sine of x cos of alpha minus cos of x sine of alpha. Okay, this one can be written as r cos of alpha sine of x minus r sine of alpha cos of x. And we need to convert this expression in the form of r sine of x minus alpha. So we can write here 5 under root 3 over 2 sine of x minus 3 over 2 cos of x. Comparing these two equations, we will have this one and this one. So we will have r cos of alpha is equals to 5 under root 3 over 2, and on the other side we will have r sine of alpha is equals to 3 over 2. Squaring both equations, we will have r square cos of square alpha is equals to 5 times 3, 25 times 3 over 4, which is equals to the 75 over 4. And on the other equation, we will have r square sine square of alpha is equals to 9 over 4. When we add these two equations, we will have r square sine square alpha plus r square cos square alpha is equals to 9 over 4 plus 75 over 4. And this one is equals to the 9 plus 75 over 4, which is equals to the 84 over 4. Taking r square common, we will have cos square alpha plus sine square alpha is equals to 21, and this one is equals to 1. So we will have r square is equals to 21 and r is equals to under root 21. So we have calculated the value of r. Now we need to find the value of alpha. If we call it 1 and equation 2, divide equation 2 by equation 1, we will have divide equation 2 by equation 1, we have r sine of alpha over r cos of alpha is equals to 3 over 2 over 5 under root 3 over 2. 2 will be cancelled out, and this one is equals to 3 over 5 under root 3, which is equals to under root 3 over 5. And in this case, r will be cancelled out, and this one is equals to tangent of alpha. So we need to find alpha. Alpha is equals to tangent inverse of under root 3 over 5, and this one is equals to the 0.3334. So we have alpha, which is equals to the 0.334. So we can say that this expression is equals to the r sine of x minus alpha, which is equals to r, which is equals to 21 times sine of x minus 0.333. Now let's move to the part B and solve the equation 5 sine 2 theta plus 1 over 6 pi minus 4 sine 2 pi equals to under root 7. For theta is less than or equal to pi and greater than or equal to 0. Give your answer correct to the two decimal values. Okay, we just calculated from part A 5 sine of x plus pi by 6 minus 4 cos of x was equals to the under root 21 sine of x minus 0.333 radian. If we have x is equals to 2 theta, this equation becomes 5 sine of 2 theta plus pi by 6 minus 4 cos of 2 theta equals to under root 21 times sine of 2 theta minus 0.333. So we can say that under root 21 sine of 2 theta minus 0.333 is equals to under root 7. Now solving this equation, we will have sine of 2 theta minus 0.333 is equals to under root 7 divided by under root 21, which is equals to under root 7 over 21. Now 2 theta minus 0.333 is equals to sine inverse of under root 7 over under root 21, which is equals to the 0.61547. This is the base angle. We know that this is sine of theta, and theta is equals to 0.6547. This is the base angle. We know that the theta angle should be in between 0 to pi. So we can have another angle in second quadrant because sine theta is positive in first and second quadrant. So we can have the another angle in the second quadrant. This angle is equals to pi minus theta. Theta in this case is, this one is theta. So we can say that this angle 2 times theta minus 0.333 is equals to 0.61547, and we can have another angle which is 2 minus theta 0.333 is equals to pi minus 0.61547. When we switch 0.33 on the right side, we will have 2 theta is equals to 0.61547 plus 0.333, and this one is equals to the 0.9488. Further solving, we will have 2 theta is equals to 0.9488 and theta is equals to 0.948 over 2, which is equals to the 0.4744. So this one is theta, which satisfies the angle condition. Theta is less than and equal to pi and greater than and equal to 0. Now we have another angle condition which says that 2 times theta minus 0.33 is equals to pi minus 0.61547, and this one is equals to 2 minus 0.33 equals to 2.5262. Okay, switching 0.33 on the right side, we will have theta is equal to 2.5262 plus 0.333, and this one is equals to the 2.8599, which is equals to 2 times theta, and theta is 2.8599 over 2, and theta is equals to 1.43. So we have two angles that satisfy the angle range. So this is the solution. So we can say that theta is equals to 0.4744 and theta is equals to 1.43.